Okay, so we're asked here to find the solution to a system of equations. Again, we can use any method. We could solve for y and graph these things and find the intersection. We could use substitution. If I was going to use substitution, I would probably solve for this x here, because even though it's 2x, 4, when we divide everything by 2, if you divide everything by 2, 4 is going to divide into, and negative 36 is going to divide into. But I've made a few videos about substitution, so I'm going to show this one using the elimination method, which I think is probably the easiest method if you know it for this particular problem. So in order to eliminate a variable, we would need to have the same number of, say, y's or the same number of x's. And then we could add them or subtract them. So what I'm noticing is that if this was 4y, these would have the same number of y's. And so in order to make this 4y, what would I have to multiply by? 2. I'm actually, though, just to save myself a little bit of trouble, I am going to multiply by negative 2 so that I'll just be able to add these two equations up. So I'm going to take this and multiply by negative 2, and then I'm going to make my new system over here. So I'm going to distribute this. That becomes minus 6x. I'm going to distribute the negative 2 into here. Minus 4y. That's what I wanted. Remember, I wanted 4y's. I want it to be negative just so it's easy for me to cancel. Minus 2 times minus 6 is going to be positive 12. So, and then I'm just going to take my other equation and move it over. 2x plus 4y equals negative 36. And I am going to add these two equations up so that these two things are going to cancel, right? So that cancels. Minus xx plus 2x is minus 4x, and that's gone, and this is equal to 12 plus negative 36, that's negative 24. And now I'm almost done solving for x here. I'm just going to divide out by 4, negative 4. So this becomes x is equal to 6. Okay, so it's looking like answer choice D is correct, but there's no way to really check this without also finding y, so I'm just going to go through that. Since I have these two equations, I can solve for y. I can pick either one of these originals. I'm going to go for the second one. So the second one is 2x plus 4y equals negative 36. But instead of x, I'm going to put in 6. So this becomes 12 plus 4y equals negative 36. And take away 12 from both sides. Divide 4 both sides. And I'm going to get y equals negative 12. Okay. So now that I have both values, the reason I did that was so that I can check. And so I will do that. I'll plug those in. Just do a quick check of my original equations here. So 3x plus 2y has to equal negative 6. So my solutions, according to my solutions, I get 3 times 6 plus 2 times negative 12, and I'm supposed to get negative 6. So 18 plus negative 24, yeah, that's going to work out. You can check it on your own if you want to. The second equation is 2x plus 4y equals negative 36. And so I get 2 times 6 plus 4 times negative 12 equals negative 36. Okay, and that's 12 plus negative 48. And it gives me negative 36. Yep, that works out. Okay, so a little bit of care is required here because it's saying what is the x value to the solution, and even though our y value was negative 12, we need to just keep track of the fact that x was 6. So our answer was 6. So we've used the elimination method. It's called the elimination because we were able to eliminate a variable by getting a set of equations, equivalent equations that we wanted. We were able to eliminate the y's and solve for x. Use that to solve for y. Check. So that's the elimination method.